The fourth question that we have is a very conceptual and a very interesting question. It is given that a point P moves on the plane given by x upon a plus y upon b plus z upon c is equal to 1. This is a fixed plane, that is the values of a, b, c are fixed. They are not variables. Now a plane through P which is perpendicular to OP meets the axis in A, B and C, and then again planes through A, B and C respectively parallel to YZ, ZX and XY planes intersect at point Q. We need to find out the locus of point Q. So the first thing in locus questions is that you assume the point to be HKL. Now we need to find out relations between HK and L. So let us begin with the information which is first given to us. Point P moves on the plane. So let the point P be equal to alpha comma beta comma gamma. It moves on the plane, therefore it lies on the plane. Let us keep accumulating the data or the information we are getting. Alpha upon A plus beta upon B plus gamma upon C is equal to 1. This is the first information that we have got. Now a plane through P which is perpendicular to OP meets the axis in A, B and C. So let us find the equation of this plane. Now since this plane passes through the point P, an equation of a plane passing through a particular point can be written as A dash into x minus alpha plus B dash into x minus y minus beta this is beta plus C dash into z minus gamma is equal to 0. This is the equation of the plane which is passing through point P. Now another information which is given to us is that this plane is perpendicular to OP. OP is the line joining the origin to the point P. Therefore the direction of the line OP is alpha I cap plus beta j cap plus gamma k cap. Now since this plane is perpendicular to this line, therefore the normal to this plane will be parallel to this line. Now the normal to this plane can be written as coefficient of x I cap plus coefficient of y, that is b dash j cap, plus coefficient of z k cap. Now both of these are parallel, therefore we can write a dash upon alpha is equal to b dash upon beta is equal to c dash upon gamma. Let this be equal to some constant equal to lambda. Therefore a dash can be written as alpha into lambda, b dash as beta into lambda and c dash as gamma into lambda. Lambda will cancel, therefore we can write alpha over here, we can write beta over here, and we can write gamma over here. So this is the equation of the plane which is passing through P and perpendicular to OP. Now this meets the axis in points A, B and C. So let us find out the coordinates of the points A, B and C. For point A is the x-intercept. Therefore it can be easily found out from this by putting y and z to be equal to 0. This comes out to be equal to alpha square minus beta plus beta square plus gamma square upon alpha. This is point A. For point B, we can write y coordinate because the point P is 0 comma y comma 0. This y will be equal to alpha square plus beta square plus gamma square upon beta. And similarly for point C, z will come out to be equal to alpha square plus beta square plus gamma square upon gamma. So we get our 3 points A, B and C. A is equal to this x comma 0 comma 0. This is x comma 0 comma 0, where x is equal to this quantity. This is 0 comma y comma 0 and this is 0 comma 0 comma z. These three are the 3 points. Now it is given that planes through ABC which are parallel to YZ, Z and X and XY planes respectively intersect in Q. We need to find out the locus of Q. So we need to find out a relation between H, K and L. So the plane through A which is parallel to YZ plane will be equal to x is equal to something. Let us draw the diagram and clearly understand this. We have x, y and z like this. Let me write this as x naught. X naught is equal to this quantity, y naught is equal to this quantity. So as to avoid confusion, z naught is equal to this quantity and this is 0, 0, z naught. Now we have this point A, that is x naught, 0, 0. So plane passing through A and parallel to YZ plane will be x is equal to x naught. This will be the equation of the plane, and any point lying on this plane will have x coordinate is equal to x naught. Now since this point Q lies on the intersection of these three planes, therefore the x coordinate of point Q will be equal to x naught. Therefore we can write the x coordinate of the point Q, that is equal to h. This is equal to x naught, that is alpha square plus beta square plus gamma square upon alpha. Now similarly we can write for y and z coordinates also. K is equal to alpha square plus beta square plus gamma square upon beta, and L is equal to alpha square plus beta square plus gamma square upon gamma. Now we have another equation, alpha upon A plus beta upon B plus gamma upon C is equal to 1. Now let us eliminate alpha and beta and gamma from these equations to get the value of, to get a relation between h, k and l. So if you look at these equations, let us first use this by substituting the values of alpha upon A, beta upon B, gamma upon C from here. So we get alpha upon A is equal to 1 upon AH into alpha square plus beta square plus gamma square plus beta upon B. We take beta and divide by B to get, this is equal to alpha square plus beta square plus gamma square. Again we'll get alpha square plus beta square plus gamma square common, that is alpha square plus beta square plus gamma square into 1 upon AH plus 1 upon BK, that is BK, plus 1 upon CL is equal to 1. This is AH. Now this summation is given to be equal to 1, therefore we can write 1 upon AH plus 1 upon BK plus 1 upon CL is equal to 1 upon alpha square plus beta square plus gamma square. Now we still need to eliminate this 1 upon alpha square plus beta square plus gamma square. So to eliminate this quantity, we look at these three equations. If we write 1 upon h is equal to alpha upon alpha square plus beta square plus gamma square. Therefore 1 upon h square, this is equal to alpha square upon alpha square plus beta square plus gamma square. Therefore we can write 1 upon h square plus 1 upon k square plus 1 upon L square to be equal to alpha square plus beta square plus gamma square upon, here we have whole square, sorry. Now when we do 1 upon h whole square plus 1 upon k whole square plus 1 upon L whole square, this will come out to be equal to alpha square plus beta square plus gamma square upon alpha square plus beta square plus gamma square whole square. Therefore we can cancel one of these from here to get 1 upon alpha square plus beta square plus gamma square is equal to 1 upon h square plus 1 upon k square plus 1 upon L square. So therefore we can write this is equal to 1 upon h square plus 1 upon k square plus 1 upon L square. Therefore we get our required relation in h, k and L, that is 1 upon ah plus 1 upon bk plus 1 upon cl. This is equal to 1 upon h square plus 1 upon k square plus 1 upon L square. Now we have got a relation which is fully in terms of h, k and L. So finally when you get a relation in terms of only h, k and L, after eliminating the variables, what you do is that you substitute h by x, k by y and L by Z to get your final answer. Therefore, our locus of the required point Q is 1 upon AX plus 1 upon BY plus 1 upon CZ is equal to 1 upon X square plus 1 upon Y square plus 1 upon Z square. So what you learn is that in locus questions, you always assume the coordinates of the moving point to be equal to HKL. You form equations, you eliminate the variables. Now after all the variables are eliminated, you substitute H by X, K by Y and L by Z to get the final answer.